Here I'm gonna cover mass defect and binding energy. So this problem is taken from OpenStax 10.2 problem number 28. So the problem is asking us to find the mass defect and the binding energy for this helium atom. So we first identify what kind of helium atom this is. It has an atomic mass number, A is equals to 4. And the atomic number is 2, which is referring to the number of protons. And this is given by Z, the notation. And the number of neutrons is simply 4 minus 2, which is because the mass number is the mass of proton plus the mass of neutrons. So here we're talking about the relationship between things that happen inside the nucleons. So the nucleus and the protons inside the nucleus, they are held with two forces. One is the attractive forces between the neutrons and the protons, or the neutrons itself, and the other forces is the repulsive forces by the charge, which is the protons. So this thing with a certain mass, and if we're separating this whole mass from these separate mass, we find that if we separate them, there is actually a larger mass, and the difference of the mass when we're converting from the E equals to mc squared, then we say that the whole nucleus plus the binding energy would be equals to if we separate the neutrons and the protons, the mass or the energy, same thing. So we're looking at the mass defects here. We have these equations which says that if I have the mass of the protons, the mass of neutrons in this case, I have 2 protons, and this is the mass of protons, 2 neutrons, the mass of 1 neutron, and I minus the whole masses of the nucleus, which is given by here for AMU, and then if I do it, then I have the energy, the mass difference, which is the mass defect, and is 3.784 times 10 to the negative 29 kg. So we have the mass defect here, and then we have to calculate the binding energy. The binding energy is basically just relates the mass defect and the binding energy from the E equals to mc squared, this equation. So if we plug in every values on it, we have 3.4056 times 10 to the negative 12 joules. And that concludes mass defect and binding energy.